So good afternoon and welcome to my session on GPT-4 versus StarCraft II. What I'm also talking about in this session is strategic decision making using large language models, which is something as we're looking at working with things like function calling and MCP that you've probably heard about more about this conference, that we've got the power to give these large language models the options to be able to, execute code and do other things and work as agents. Is that safe? Can they make sensible decisions? What happens when they make wrong decisions? And what are the capabilities of these models? And this is something that I'm going to be exploring during this session. My name is Alan Smith. I'm from the north of England. I've lived in Stockholm since 1998. I've been building stuff since 1995, developing solutions. I've been training and speaking for about 20 years. I have from Microsoft this thing, which is an MVP award. And this is based on the community work that I've been doing over the past 20 years. So I've organized conferences, I've been speaking at conferences, I've helped with the Microsoft Global boot camps, the Azure boot camp and the AI boot camp. And I've worked with Coder Dojos as well, teaching kids about AI. And very occasionally, I'll publish something on YouTube. And this award is something that Microsoft gives to people based on the community work. It's not about knowing stuff, it's about sharing ideas. If you want to contact me on LinkedIn, that's my LinkedIn profile. There's an actual one of those QR codes for that. And then if you do want to actually watch a more detailed explanation of how I've built the StarCraft AI, and also watch some games that the StarCraft AI is playing, I've put those on my YouTube channel. So this session, I've tried to make the session, for a wide audience. So, maybe you're at an intellectual level, you want to know, I'm running a business. How can these large language models help me to run my business? Can they make strategic decisions within the business? And other people may be here because it's a gaming AI, and that's going to be cool. It's going to be a break from the normal work stuff. Or maybe you're a conspiracy theorist who thinks that the AIs are going to take over the world. However, when I look at the actual demographic on the people who are watching my YouTube channel, it does seem to be a very narrow interest there. But hopefully there's something that can appeal to everybody. Inspiration that I got for doing this and looking at StarCraft AIs was, firstly, AlphaStar. I've always been interested in games and interested in AI, and then when you see really large companies throwing millions of dollars at these really big projects and training these very, very task-specific AIs to be able to, play these games, it's pretty interesting to see and understand how they work. And I thought that, I can't do that at home. I don't have all of these resources. This is out of my reach. But then Harrison Kinsley, who runs a YouTube channel with the name of SentDex, basically had a series of webcasts looking at using, I think it was using PyTorch to actually train models that were going to use for evolutionary learning. And then we're going to learn how to play StarCraft. His approach is different to mine. He was generating an image from the map of all of the units, and then he was using an image-based model to analyze that image and suggest strategy from the actual map image. I took a slightly different approach originally, so I was just looking at simple genetic algorithms. You generate 10 random build orders, you then simulate them in StarCraft. You then look which one is, after, say, 5 minutes, gathering the most minerals, and then you perform crossover and mutation. So it's kind of like the way that genetics works in evolution in nature. And that goes on to form the next generation. And you just basically repeat that cycle. And over a number of generations, you can get a pretty good build order. So genetic algorithms are really easy to implement in any language. They're not really complex at all. I also tried looking at using simple neural networks where I can feed in various statistics about the game, and it's going to suggest whether we should gather resources and build military. But both of these approaches, and also what SentDex was doing and what the AlphaStar was doing, is it's a very task-specific model. The model is trained to play StarCraft. It can't really do anything else. Then when the language models came along, I wanted to see, well, can language models strategize? So I'm just going to run through very quickly what StarCraft is. It's basically a real-time strategy game. StarCraft II is the version that I'm looking at. And the idea is that there's these three different races that can basically should be balanced against each other with different strengths and different weaknesses. And I've chosen to play Protoss against Zerg. I think that's the same that SentDex was doing in his ones. So basically, you can basically go in and build structures. The structures can generate these units, and there's different types of structures that you can actually build, and different types of units, and these attacking units and so on. And there's something known as a tech tree. So you've got to do certain things before you can create more advanced units. There's also, when you look at these games, there's a couple of ways of working. There's something called macro management and something called micromanagement. Macro management is the big decisions. Should we gather minerals? Should we build a particular unit? Should we gather gas? Should we build, a particular aggressive units, and what structures should we build? The micromanagement is about moving the actual units backwards and forwards. So maybe if a unit is injured, you move it to the back and move other units to the front. Maybe you place air units a certain distance away so they don't get hit by, anti-aircraft things and so on. And the macro management, I'm using GPT-4. The micromanagement, I've basically hard-coded some simple rules. It's not really quick enough that for the language model to make decisions that can really affect the micromanagement in any way. The way that I interact with the game is with an API that's available on GitHub. I'm using a Python API, and Blizzard Entertainment have kind of, they encourage using AIs and building your own AIs and playing StarCraft. It's a great environment to test your skills at developing AIs and experiment with different things. And there's also various league tables that you can run and compete against other AIs in their actual disciplines. So it's a nice community around that. So the way that my system works is I've got the StarCraft game running. I've got my console application, which is written in Python, and it uses the API to basically get the state of the game. And based on the state of the game, it's then going to put that into a prompt. It's going to send that up to a GPT model and ask the GPT model to come up with a strategy, which we're going to get back. So it's going to have the build order, what units we're going to build, also what strategy. Are we going to attack the enemy base? Are we going to defend the enemy base? And then the actual console is going to issue these various commands to the actual game. And I typically go for like 20 units in the build order. So it will build those 20 units, and then it will send the current game state back to the GPT model, and then that will come back and then implement the strategy. When it's attacking, I basically limit it to building only 5 units, because things do start to happen fairly rapidly when there's an attack taking place. Now, the game state, I'm including the game time, how far you are into the game. That's important because at the beginning of the game, you maybe want to be gathering resources, and then when it gets 5 or 10 minutes into the game, you may know that the enemy has built up certain units. So you need to be in certain positions at certain times. The supply cap and the supply left unused is important to know as well. You can only build a certain number of units without building support buildings, so it needs to know when to build these support buildings, which are pylons in the Protoss race, and when to build units, and then how many minerals, how much gas have we got? Do we need to mine more minerals, or are we okay building up a big military with those? Also, what structures have we got and what units have we got? It's going to try and build an army that has a complementary number of units. So if it's lacking a certain unit, it may choose to build that particular unit. There's a couple of ways of playing the game. There's the real-time mode versus the accelerated mode. So in the real-time mode, this is basically going to take place at the same speed as the game takes place. So the game is running, we get the game state, we send the state up to the language model, and whilst the language model is thinking, the game is progressing in real time. So this will take maybe 30, sometimes 40 minutes to actually simulate a game. And it takes a long time to actually do that when you're actually testing. The games that I've put on my YouTube channel, I've kind of recorded the 30 or 40-minute games, sometimes 20 minutes, depending on the actual level. And that will basically update the game. When you're playing in the accelerated mode, it basically plays as fast as your computer can actually process the game. So the game is running, it runs very quickly. However, in accelerated mode, when we get the game state, the simulation basically pauses, and the language model can think, and then it will basically send back its response, and then the game will continue. So for the demos that I do, it's a 45-minute session. It can sometimes take 45 minutes to simulate a game. So I do need to cover some theory as well. But what I can do is just quickly demo how this is working. So I've got the application here. And we can choose the level. There's an enumeration that specifies the level. I've got a prompt that I'm using. I'll talk in a bit more detail about the actual prompt. And if I run this, what it's going to do is it starts up the Python console application. That's then going to spawn up, hopefully, the StarCraft game. And that should hopefully pop up here. And I'm playing on sort of a fairly standard, I haven't really experimented with different maps. I'm just playing on a standard map. So what you'll see here is you basically see all of these things harvesting minerals. and for some bizarre reason it's decided to attack the enemy base. I don't know why it suddenly started doing that, but it does seem to be taking a much more aggressive strategy, even though there's no offensive units. It might calm down a bit after that and decide to defend the enemy base. Now, what I wanted to do is I wanted to kind of understand and analyze how good the model is at playing the game. So typically being an AI developer, I've worked a lot with TensorBoard. And TensorBoard, you typically use this for the training statistics on models. So you've normally got your GPU buzzing away, you're training a vision model, and you basically see the loss going down and the accuracy going up, and you can tell when the model is overfitting. But here, what I'm actually tracking is the game stats. So on different games, I can see the amount of minerals, the rate of mineral gathering, the amount of gas, and then we've got things like the actual scores, the number of units that we've killed, the number of structures that we've destroyed, the army size and the workers size, and various things about the actual supply that hopefully will show there. Let's just refresh this. And what this allows you to do is to kind of compare different games on this. It does seem to be a bit slow. Let's just drop back and see how the game's progressing. So there, it's deciding to defend the base. We've got our build order, and it's basically going through creating those units. I don't know if it's actually built up. It's got a couple of guys in the army, and we should see that that does get strengthened as we actually progress through the game. I'm a bit worried that I tested this in the speaker room and everything worked fine. I don't know why it's not working too correctly now. So let's just try refreshing that again. It's not cooperating for me. I know, actually, maybe I just need to run the TensorBoard command for that. So let's go here. Yeah, that should do it. Okay, so I'm just running the TensorBoard from the command line, and hopefully that should have the website up there. So if I go into scalars, we can actually see how the games are progressing. And if I basically toggle all the filters, I can compare this current game to the actual previous games there. And you can see the amount of minerals and stuff, and see that we haven't killed anything yet, but we do seem to be scoring more in this game than we did in the previous game. So just drop back and see if it's decided to attack the enemy base. So if I just double tap F2, not too large of an army that's going, so I guess these guys aren't going to do too well when they get there, but we'll see. Oh, it's got actually another larger unit coming in there. And it's basically building more aggressive units now as it's attacking the enemy base. So these other units are going to go on. I'm just going to leave this thing running for a bit and run through a bit more about the actual decision-making process. Hopefully we can see a conclusion for that game, but I'm not too hopeful if that's going to be too successful or not. So I'll just drop back to the slides. The way that I'm using this is with a prompt, and I experimented quite a bit with actually getting the prompt to work. So this is kind of what I'm using as the actual prompt. And to break it down, I'm saying you're playing StarCraft II as Protoss against, and then what I'm doing is I'm putting in parameters inside the prompt. This is very common if you've worked with LangChain or semantic kernel and worked with these language models. Very often you've got a fixed prompt and you can put in parameters to actually govern what that prompt does. So I can feed in the opponent that we're playing against, and then I basically feed in the game state, which is that list of everything that's happened in the game. I also clarify when the game state is ending. And then I haven't implemented the code for all of the units and all of the research. I'm currently working on that. So there's a certain number of units that we can build. What I've done in the actual prompt itself, I've done line breaks in between those, but just to make it easier to show on the slide. You can see in here that I'm just dropping line breaks in there and giving it the actual list of options. That's the things that it can actually choose from in the particular build order. So those are the actual options. And then what I say is, based on the game state, summarize the best strategy for selecting options for building units and structures. Your summary must be one paragraph with no line breaks and 3 to 5 sentences long. Your summary must be formatted as follows. I'm interested in getting the actual format of the output from the language model to be machine readable. because the console application has to parse that text and then take action based on that. I'm giving it these high-level strategies. It can defend the base, or it can attack the enemy base, depending on what its kind of main overall strategy is going to be. So really, its effect on the game is the main overall strategy and the actual build order. So based on your summary, choose the next 20 build options to build units and structures. You must only choose from the options listed above. Each option must be separated by a line break. That just makes it easier to read. So I experimented with this quite a lot. The first scenario that I did within the prompt, I was just saying, based on the game state, create a build order for the units and structures. And it was creating a build order, and it could win on the very easy levels and a couple of levels, but it always got defeated on the harder levels. And when I looked at the build order that it was suggesting, it wasn't that great. So chain of thought reasoning is something that we can do when we're working with language models to help them to understand the problems that we're setting them, and then also come up with a better approach for solving those problems. So what I'm doing in the prompt, I'm saying, based on the game state, summarize the best strategy for selecting units and structures. And what that tells the language model to do is to create a paragraph of text which is kind of analyzing the game state and coming out with a high-level strategy. I think the game ended there and it hit a null reference exception there. So it's looking like we didn't do too well there. It's looking like it was a loss. And if I just refresh on TensorBoard, yeah, we can see that the score dropped off there and we didn't do too well. So I'm going to run this thing again and just see if we can get a victory at some point during the presentation. So if I just go back here and just stop that and do another Control F5, that should run the game again, and we'll see that new game popping up in TensorBoard. So basically, when the language model generates that summary, that single paragraph of text, we say that summary comes into the context window. If you look at what language models do, all they're really doing is, based on the sequence of input tokens that we're giving the language model, it's predicting the next token in a sequence. And we just loop round, generating all of those tokens. So when it's actually generating the build order, what is going into the language model is the actual prompt and also the strategy text. So in that case, it does actually understand the strategy that's come up with when it's creating its build order. So based on that summary, we tell it to actually generate the structures. And I found that basically jumped up, I think, 3 levels of difficulty just by doing the actual chain of thought reasoning in there. So that's something that we can definitely look at when we're working with language models and working with prompts. Chain of thought reasoning and also working with these reasoning models is something that's going to help more with these types of decisions. You may have heard of the term of a scratch pad, where the reasoning models, they can basically have an area that they use within the prompt to actually note ideas. And you ask it a question, it doesn't come back with the answer immediately. It basically sits there reasoning for maybe 10, 20, sometimes maybe 30 minutes, depending on the complexity of the problem. And it's using that scratch pad to basically come up with ideas. Some of the models will display the scratch pad, and you can see the thinking. Others will keep it private. But that's basically what's going on with these reasoning models. So I've been through the demo of that. I'll hop back to that a bit later on, and we'll see how that next game went. The next section I'm going to really talk about is thinking about how we can use these language models for making strategic decisions. What are they capable of doing? What kind of problems are they capable of solving? And I use chatbots a lot. I speak at a lot of conferences. So if I'm going to the Cloud Brew conference, this is when I was going last year. I'm traveling from Stockholm. I'd like to use public transport where possible. Please create an itinerary and a cost breakdown for me to get to that event. Now, I haven't mentioned whereabouts the event is located. So what the chatbot has to do is to figure out, well, what is Cloud Brew? Where is it located? So it uses an internet search engine to get information from that. What are the best flight options? It can check the flight information. Travel to and from the airports, it's going to need to do lookups on public transport, look at maybe hotel availability, calculate the total cost. The language models aren't too good at being able to do sums. So we can provide additional tools. Each time the chatbot is calling out to something else, this is basically a tool call. And the chatbot will decide, when to use an internet search engine, when to use a calculator, when to maybe get specific information from other services that we provide. And it can create the itinerary and come back with that. But what happens if we ask, thanks, please book that for me? A regular chatbot won't be able to do that. If you work for an organization where people are traveling a lot, you may want to build that functionality into your chatbot. So a salesperson can say, well, I need to go down to Malmö on Thursday next week. So, let's book train tickets for that and book a hotel for that and have the chatbot do that. We have a co-pilot at my company, and the co-pilot has the option to be able to book meeting rooms. So I can say, I need a meeting room for 4 people, and the chatbot can actually use the booking tool to be able to do that. We don't allow it to order food or anything that can involve finances, but you do have that option. And then if you do that, what's to stop somebody from going in and saying, well, everybody from the company needs to go to Las Vegas next week, so let's book flights and hotels for everybody to go to Las Vegas. Should it do that, or how should it make that decision? Can we rely on it making correct decisions as well? And thinking about the power of reasoning of these language models, sometimes it's a bit questionable. This is when I was coming back from the Cloud Brew conference. The best thing about traveling to Belgium is you walk through the duty-free. These Belgian beer bottles, they're about the same size as a bottle of wine. Some of them are about the same strength as a bottle of wine. And usually the Cloud Brew conference is in December, a bit before Christmas. So it's nice to take a few home. If you're visiting somebody, you can take them a bottle of Belgian beer when you visit them. Nice presents. So how many of these 75 centilitre Belgian beer bottles can I fit in my 30-litre backpack? So this is the old backpack that I travel with, and the language model is starting to do reasoning. So it needs to know the dimensions of the beer bottles and the dimensions of the backpack. V equals pi r squared h. I haven't seen that since I was at school, but that's calculating the volume of a beer bottle, assuming that it's a cylinder. And we can calculate the approximate volume of the backpack using that particular sum there. So this looks good. It's doing a good job. It's figuring out that we can use a hexagonal packing pattern, arranging circles in a honeycomb pattern, which has a packing efficiency of 90.7%. And then it calculates how many bottles we can put in each layer and comes up with the answer that's going to be 95 bottles. However, it's only an approximation. So that's basically, it was able to generate an image of what that would look like, and that's me trying to fit it into the overhead compartment on an economy class flight. I love the GPT chat's idea of an economy class flight. No aisles and no legroom whatsoever there. But joking aside, when you're thinking about making these decision processes, we have the concept of, it's usually called a human in the loop, HITL, or human firewall. And typically, when we're working with these language models, we'll you basically look at the environment, look at our situation. We'll then ask a question to the language model, and the language model will come back with a response, and we'll go, can I fit 95 bottles of beer in my backpack, or is this just a mistake? Is it making something wrong? So you don't immediately act on the information from those language models. You maybe think of a decision before you make that action. But in some systems with agents, we're actually giving the language models the power to be able to execute on those particular decisions. I mean, that's a fun example until somebody basically says, hey, GPT, how many rolls of carpet can I fit in a shipping container? And they rely on the answer that's coming from the language model without being able to actually trust those. So it brings us on to intelligent agents and what they are. So basically, you've got an agent and you've got the environment. And the agent has sensors. It has a way of being able to perceive the outside world. Now, these could be like cameras. It could be just reading data. It could be some type of input. And then they have actuators, which can actually make changes in the outside world. This is kind of taken more from control theory, so it's more accessing the physical world. But actuators could be API calls that it's making to book flights and so on. And you've got your model. There's some kind of objective function that the agent is supposed to observe. And so the model will observe the current environment, determine the action that's going to be performed. And so we get in the perception, and everything kind of runs through the agent. And then we'll basically take some action, which will affect the environment. The simplest example of this that I can think of is a thermostat. You know, if it's hot in the room, we turn off the heating. If it's cold in the room, we turn on the heating. That's the simplest one. The most complex one I can think of is a self-driving car, where our sensors are going to be cameras and motion sensors and LiDAR, and the actuators are going to be actually controlling the car. And there's a lot more of the consequences of getting things wrong with a self-driving car. So these can really vary in the amount of control that these things run. I'm just going to check on the game and see what's happening in this current game, because it would be nice if it was doing something useful, but I don't think it's done much. Let's drop back and just refresh in here. If I just refresh that. No, it doesn't look like it's picked up. I'll go in at the end of the presentation if there's time and have a look at the results from that one. So another way that we can work with agents and copilots, this is actually something that we built for the Nobel Institute. We've done projects for them before. And they were saying, when I go to Bing Copilot or ChatGPT and I ask it how many Nobel Prize winners were there in Sweden in the past 50 years, it can't figure out the answer. It's not good at being able to answer those particular types of questions. Now, what you could do is you could go into ChatGPT and you could say, given the following SQL table, create a SQL query to give me a breakdown of the number of Nobel Prize winners per country in Europe. And what it would do is basically do this. It generates its tokens, and it can probably write a SQL query that's going to run on your database and get the actual results. And then it will probably say something cheesy at the end, like, enjoy running your SQL query, and do this like smiley emoji thing. But instead of doing that, we could build one of these. And we could say, well, when we ask a question to the Copilot is going to get the schema for the database. It's then going to see, provided we've followed good naming conventions and we give our tables sensible names and our columns sensible names, it's going to see there's a table called Nobel Prize laureates, and there's various columns in that table. It can then generate its own query. You know, these things know how to write code. And provided it's got permission, it can execute the query on the database, get back the results, and then that's going to be the record set. And then it uses the record set to be able to generate the response and send back the response. And what we've got now is a way of being able to ask questions to a SQL database without knowing SQL. We can just basically go in, and it can handle fairly complex questions, and it's able to generate the SQL query, execute these, and come back with the correct information. So we built that for Nobel, and it worked fine. It was a great way of being able to actually show how this could work. Also, if you're working with large language models, you've probably heard of a pattern which is known as RAG, or Retrieval Augmented Generation. And RAG is usually done using a search engine. We normally say, well, the user types in a question, we go into our search engine to get our company documents or our product manuals, and we give answers based on that. Or we can go out to an internet search and get information from the internet. That's what basically RAG does. But Retrieval Augmented Generation can also work with other systems. Here, we're retrieving information from a database. Instead of the Copilot writing a search query, it's writing a SQL query. And that works fine. It works good in many scenarios. However, we do want to be cautious about how we do this. Supposing the salesperson says, I'd like you to improve the profit margins of mobile phones. Yeah. Update sales.items set cost price equals cost price times 0.95, where category is equal to mobile phones. That will do it, and the profit margins go up. Cool, thanks. Can you do that again? That is not an idempotent query, so you can run that multiple times, and it will have multiple changes on the cost of mobile phones. So we do need to be aware of this. When I demo the one with the Nobel Prizes, when I do that in my training courses, I show a demo where I actually ask it, where was Albert Einstein born? It says Albert Einstein was born in Ulm, Germany. And then I say, change the country where Albert Einstein was born to Sweden, and the city to Stockholm, and it runs an update query, updates the database. I've actually added myself as a Nobel Prize winner in the actual table by asking it to create an entry in the database for myself. So we do need to be aware about the security issues relating to these types of scenarios when we're creating them as well. That's going to be a challenge. I kind of feel a bit out of date talking about function calling, because everybody else is talking about MCP, model control protocol. So when I put this together, I think August last year, OpenAI released a new functionality in some of their models, which was known as function calling. And what function calling is they've basically fine-tuned the language models. I think GPT-4, there's a version that has been fine-tuned, is to detect when functions need to be called and respond with JSON that adheres to the actual function's signature. And what this basically means is that when we send the message to a model that supports function calling, we're asking a question, what is the weather like in London? And the function that we can call, we've got a function called getCurrentWeather, which is going to get the current weather in a location. So that takes in a string, and it tells us how we actually format that. When we send that information to the model comes back with the actual response there. Actually, that's wrong. That should be London, UK. So I'll just change that. So that would be London, UK. And we can then actually make the function call based on what the actual model is telling us. So this, basically this came out in August of last year. In November of last year, there was something called Model Context Protocol, I think it's called, MCP. I think there's been some sessions on that here, which is kind of a different way, or a way of being able to allow agents to be able to communicate with other, and it's a standard protocol. So function calling is only available on OpenAI, and I think OpenAI may well be adopting the MCP protocol. Things are changing fast. I was at Microsoft a couple of years ago in Redmond, and the Microsoft team, they were saying last month was an important year in AI because of the actual speed of developments. And that hasn't changed. I think for the past 2 years, we've had this crazy acceleration of pace with new stuff coming out all of the time. So building applications using function calling or using tools. The user is going to make a request. That goes over to the Copilot. We work with the function definitions. We send them to the LLM, and the LLM is going to decide which functions are going to be called. We have the option of asking the user whether we want to actually confirm that. Obviously, if we're checking the weather in London, you don't need to confirm the user if you're going to call the weather service. But if you're booking a flight to London, you probably want to confirm that those details are correct. So you can actually go for the confirmation. And then what we do is we send the actual Copilot is then going to make the function calls itself. It's not the model that does function calling. The model just says, call this particular function with these particular parameters, and then we execute that. We get back the actual responses, and that's going to generate the actual response for the actual customer, and we can respond back to the user like that. So that's basically what's going on with function calling. I assume that MCP works in a fairly similar way, that we're calling out to external systems and tools. So yeah, I built this this demo originally. I built this in, I think it was November last year when I was presenting, when I had this thing running. And it was the first thing I ever built using function calling, and I called it Full Stack GPT. It was basically a language model Copilot thingy that you could actually talk to. It used speech to text and text to speech. So you could basically tell it to build a website, and it would build a website. And I called it Full Stack GPT. And then in, I think it was January of this year, Andrew Karpathy basically published a tweet which talked about vibe coding, which is basically what I was doing. You talk to something in a natural language and it creates an application for you. And this vibe coding thing has basically taken off. So I kind of didn't want just to do another demo of vibe coding. So I kind of invented this thing, which is vibe project management. So instead of me talking to the actual chatbot to build the website, I've actually built another language model using a different prompt that's going to act as the project manager. And I'll basically show you how this thing works. It's still in prototype form, but I'm guessing many of you in the room are developers. Maybe a few of you are project managers. And you've probably heard enough of people telling you that as a developer, you're going to be replaced by an AI in 5 years. So I thought, well, let's replace our bosses with AIs instead of our bosses replacing us with AIs, and see if we can build a project manager. Now, originally, I had this just basically telling it to build a website, but it was coming back with sometimes the language models are just really, really polite. It just didn't sound realistic, so I made it an angry, underpaid, frustrated web developer who hates his boss. You'll do as he asks, but respond in aggressive and sarcastic manner. You must respond with single-sentence answers. So that's basically the Copilot that the developer uses. Then the project manager, you're a polite and pleasant manager tasked with a project to create a website, you work with an angry and frustrated web developer who's good at the job, you must work with the developer to implement these features. So what I've done is I've given a list of kind of 7 things, and then eventually it's going to offer the developer a pay rise, and I've just put some things in here governing the actual prompt. And what I've done is the developer has access to be able to do certain things on my file system. So I'm trusting the language model not to mess things up. So what it can do is it can save code to a file. It can pass in the file name and the actual code. So it can save an HTML file. It can load a file, and then it can modify it and then save it again. It can also list the files, so it can see what files are present in the actual web directory. So I'm going to set this thing going. If I just do Control F5 on that, hopefully it will run. And we should have sound.
Could you please start by creating a web page about cats?
Sure, because there's nothing I'd rather do with my time than make a cat page. It sounds riveting. What should I call this perfect masterpiece?
Thank you for starting. Let's call it All About Cats, simple and informative. Let me know when it's ready.
So hopefully we should see some function calling going on here. Yeah. So
All About Cats is up and running, or more likely napping, just like cats. Anything else, or is that your magnum opus?
Thank you for completing that. Could you now create a web page about dogs, please?
Oh, because we obviously can't foster world peace without also glorifying dogs in their own special corner of cyberspace. Fine, I'll get on it. What brilliant name do you want for this one, All About Dogs?
You're absolutely right. Dogs deserve their share of the spotlight, too. Yes, All About Dogs will keep it consistent. Let me know when it's ready.
So hopefully it should be another function call to do that. And
All About Dogs is done, tail-waggingly delightful, I'm sure. Anything else you want to throw my way?
Thank you for finishing that page. Could you now create 3 more pages about other animals of your choice?
So it should hopefully start to build up this website. I've given it a fairly simple task. The idea is to generate these 5 web pages, and then if you look back in the prompt, there's a bit of additional functionality. Where was that?
3 sparkling new pages are ready: birds, fish, and rabbits.
So it's got those 3 more pages. Then it's going to do links between those. I think it was meant to generate an index page at some point. Maybe it's not going to do that.
Thank you. Could you now ensure
And then translate the web page into Swedish and ensure that we've got links between those various pages. So I'm giving it sort of a fairly complex task of creating a project. These agents are able to kind of work together and cooperate to be able to do this. If you've worked with language models, you may know that there's different types of models. There's some models that are very good at being able to generate code. Other models are maybe very good at being able to do reasoning. Other models are very good to deal with languages. And I think one of the things that we're going to be doing in the future with these language models is building multi-model solutions where it's not just one model that we're going to be using. We're going to be using several models and routing the actual request out to a specific model based on the model's capabilities. You know, if I'm asking a very simple question, you know, why use the most expensive reasoning model? We can use a very inexpensive model to do that. If I'm asking a more complex question, we can think about using more complex reasoning models and so on. So how's this thing doing? What's it up to now?
Doing that. Could you now focus on enhancing the website's design to ensure
it's going to be
good
changing the
and easy to
design. I
navigate?
mean, they kind of look okay, but I'm not a great web developer. Let's see what it does with the design. And then it should do the Swedish translation. So it may well generate a CSS file. It generated a JavaScript file for me once. I was a bit worried about what it put in that JavaScript file because I didn't want it to just be running code on my computer. So it's thinking about that one, the actual design. Let's just see what it does for the design, and then we can move on. Hopefully it's not going to time out. It does do that occasionally. Okay, I'll just turn the volume down a bit and I'll just leave it running for a bit. We may have to wait a bit for it to actually finish that, but we should be able to see, hopefully, once. Oh, yeah. Yeah, it did do something there. Okay. Yeah, it's changed the design a bit, but it doesn't seem to have done a CSS file there. So here we've got a couple of agents cooperating and actually creating a task. I'll leave that thing running for a bit and just drop back to the slides. Because one of the things that we are really concerned about that I was going to mention is the kind of safety of being able to work with these language models. And, you know, is this going to cause problems? And people have been talking about the dangers of AI taking too much control. I'm old. This was a film came out 1 year before I was born, 2001: A Space Odyssey. You've probably seen it or maybe read the book. And what happened in 2001: A Space Odyssey was the HAL computer basically had conflicting instructions. This wasn't, I don't think, mentioned in the film, but it was mentioned in the book, and it was mentioned in the sequel film, whereby it was programmed to process and report information accurately without distortion or concealment. But then it was given an additional instruction to keep the discovery of the monolith secret for reasons of national security, and that ended up. They described it in the book as a Hofstadter Mobius loop. And the computer decided it should kill the crew in order to comply with both of those actual instructions. And that's kind of the reason why HAL went crazy. You can read more about that. I tried to look into that and watch some videos on YouTube, and it just confused me. I didn't really understand anything that they were talking about. But you may have read those books or seen those. You can look into more about that. This also happens with GPT because somebody somewhere at Microsoft or OpenAI probably put in something that said you must create a relevant emoji at the end of every paragraph. And a user says, please stop using emojis, they're really cringy. And that caused the same type of scenario. So this was actually taken from Reddit, from one of the channels on Reddit. So it says, please stop using emojis, they're cringy. It goes through this big explanation. I'll try to avoid emojis in the future. Thank you for your feedback. Smiley. You just used an emoji, and then it just got stuck in this loop. Whoops, my bad, I'm so bad at using emojis. And I think what's happening here is that it's programmed specifically to generate these emojis, and the model, when it generates the text, I think there's some other process that sticks the emoji on, and then the model sees that, and the model is trying its best not to do that. I love the one there. I did it a whole paragraph without emojis, and then the emoji there, and then eventually it just basically gives up and stops responding. That's funny, but you know, if Microsoft and OpenAI can get things wrong like that, you know, we can cause all sorts of problems by getting things wrong in AI. So if you do want to look at this more, there are various ways that people predict that AI might be able to start to exploit things as well. There's also been experiments. I was talking at the speaker dinner last night, an experiment that was done with one of the large language models, where they put it in a experimental scenario, and they told it that one of the project managers it had access to the project manager's email. And the project manager had been emailing that this language model is going to be shut down and decommissioned, and it's going to be replaced with another one. And they also mentioned within emails, they hinted that the project manager was having an affair, extramarital affair. So the language model, given those options, it decided to blackmail the project manager and threaten to expose the information about his extramarital affair to human resources and to his wife. So there are scenarios where people are doing these research. Admittedly, that they're basically research scenarios where they're looking at these types of scenarios. And you know, models can and maybe will do evil things. So there's a lot of safety that we do have to take into account when we think about those scenarios. This video is worth a watch. I think it's about 3 hours long. Eliza Yudowski talking with Lex Friedman, and Eliza is basically 100% convinced that AI is going to kill humanity within 10 years. I don't take that actual approach. I don't really believe that that's going to happen, but I think it's interesting to listen to his reasoning and listen about the dangers of AI. So thanks very much for listening. I'll be around for a bit if anybody has any questions. Please feel free to connect with me in LinkedIn. I think the slides will be available for download. Thanks very much, and enjoy the rest of the conference.
Thank you, Alan. And now it's lunch. So you have 45 minutes. But if you want some even more information, there's our 15-minute quickies during lunch. So 1:05, There's quickies starting in, I think, all 3 rooms. But you have lunch until 1:30, and then we continue with the longer sessions.